In section 3, we're going to talk about combining solids. So most applications of three-dimensional solids involve combining two or more of them. So when we're talking about finding the volume of those combined solids, we find the volume of each solid separately, and we add together if the figures are on top of each other, and we subtract if one figure is inside another. So we're either going to be adding or subtracting volumes of composite solids. When it comes to surface area, you basically just figure out what sides are exposed and find the area individually of those sides and add them together. So there's no real method for finding surface area of combined solids like there is for volume. So in our first example, we have that you want to get ice cream and want to know how much ice cream you will eat based on the number of scoops. You decide to get a waffle cone that is 6 inches deep and 2 inches wide, and we want to know how many gallons of ice cream for 1 scoop, 2 scoops, and 3 scoops. Just kind of think about what this looks like. So a waffle cone is a cylinder, and then our ice cream scoops, a cone, and then our ice cream scoops would kind of go on top. So for our cone, we know that it is 6 inches deep, and then we know the diameter going across is 2 inches. And that's all we really need to know to figure out how many gallons of ice cream we're going to have. The ice cream scoops, when we're trying to figure out, what solid do we use for those, the ice cream scoops are going to be hemispheres. They're going to be half a sphere, because once you compact them, they're not really like a full sphere sitting on top of each other. They're going to be half a sphere on top. So we're going to start with the volume of the cone. So volume of the cone is going to be 1/3 pi times our radius. So if our diameter is 2, our radius is 1 squared times our height, which is 6. And again, not going to leave it in terms of pi. We're going to go ahead and put the decimal. So the volume of the cone is 6.28 inches cubed. Now for our ice cream scoops. So if we want to find the volume of 1 scoop, so that's the volume of 1 hemisphere, we do 1/2 times the volume of a sphere, which is 4/3 pi times the radius cubed. And in this case, since the ice cream scoops are going to fit across the waffle cone, they have the same radius as the waffle cone, which is going to be 1. So we have 1/2 times 4/3 times pi, basically. So 1 scoop has a volume of 2.09 inches cubed. So for 1 scoop, you add, so 6.28 plus 2.09 is going to give us 8.37 inches cubed. But I want to know how many gallons of ice cream that is. And I do give you a conversion here that there are 231 cubic inches in a gallon. So we're going to divide that by 231. And we're going to get 0.036 gallons. For 2 scoops, so we're going to have to take 2.09 and multiply it by 2, because we now have 2 scoops. Then we add the 6.28, and we get 10.46 cubic inches, which will then divide by the 231, which is 0.045 gallons. And then lastly, for 3 scoops, we'll take the 2.09 times 3 plus the 6.28. So 12.55 inches cubed. Then we'll divide by 231. And we're going to get 0.054 gallons. So not a lot of gallons of ice cream in 1, 2, and 3 scoops based on the size of this waffle cone. So you should feel a little bit good about yourself when you order ice cream. Get all 3 scoops if you want. It's not a whole lot of ice cream. Now we're going to come back to the shed example from section 2. So you're building a shed with the following dimensions, and you need to purchase wood and need to know the surface area. Windows and doors will be cut out later. How many square feet of wood is needed to build the shed? So this is kind of an example of a surface area problem. So I only need to know the area of whatever surfaces are on the outside of my figure. And I can't see all of them, like I can't see the one like left side or the back, but we're gonna pretend we know they're there. So my composite solid here is made up of a rectangular prism and a triangular prism. And unlike volume, where you can just add and subtract, I can't do that for surface area because there is a part of the figure that is inside our composite instead of outside, and we only care about the stuff that's going to be outside. So I'm going to start with the surface area of the rectangular prism. So if I'm looking, I've got the base. We're going to keep the same base we did in the previous, so we have our base. Both of those sides are exposed on the outside, so I'll still do 2 times the area of my base, which is going to be 20 times 15. For the other rectangles, I don't actually need to do the full perimeter for my surface area because there is one rectangle that is actually inside the figure. So I only have 3 rectangles that are going to be needed. And there's the rectangle on this right side, and there's one directly across from it, so we'll have 2 of those rectangles, and then there's the rectangle that's on the bottom. So when it comes to the remaining surface areas, I have 2 45 by 15s, and then I have the one that's on the bottom, which is a 20 by 45. So 20 times 15 times 2 is 600. 45 times 15 times 2 is 1350. And then 20 times 45, which is 2250. So 600 plus 1350 plus 2250 is going to give us a surface area of 4,200 square feet. So that's the first part. Now I need to find the surface area of the triangular prism. So for that figure, we have our triangle base, and there are 2 of those. So we'll do 2, and then area of the base, 1/2 times my base, which is 20, times my height, which is 4. And then there are only 2 rectangular sides that we have for our triangular prism. We have the sides of the roof, and there are 2 of them that are exposed. So for their area, we'll have 2 times, and then we have the one side that is 45. Now, unless you're told otherwise, we're going to go ahead and say that that's an equilateral triangle. Most of the time when we do triangular prisms, the bases are going to be equilateral triangles. So all 3 sides are going to be 20. So we'll have times the 20. Now I can go ahead. We'll have 1/2 times 20 times 4, which and then times 2. So the 2 and the 1/2 are going to pretty much cancel each out, and we'll have 80. And then we have 2 times 45 times 20, which is 1,800. And we're going to add those together, and we get the surface area of the triangular prism is 1,880 feet squared. So our total surface area, we're going to add together. We're going to do 4,200 plus the 1,880. And we're going to get 6,080 square feet. So that's how much wood would need to be purchased to construct our shed. And then we can cut out windows and doors later. So let me know if you have any questions about volume or surface area of composite solids.